Now, probability with replacement, we already talked about it. And in this video, we'll look at probability without replacement. Without replacement. Now, probability without replacement, what we need to know that when you get something, you don't take it back. That means you are disturbing the total and the actual possible outcome of each and every individual that is there. Let's say you have 8 blue pens and 5 green pens. Okay? Then I say 2 pens are picked at random without replacement. Without replacement. One after the other. After the other. So, find the probability that the 2 pens are A, both blue, both green, and blue. Now, how do we answer this type of question? 8 pens, 8 blue pens, 5 green pens. Both pens, you pick 2 pens without replacement. That means when you pick a pen, you don't take it back. Again, you pick another one. Now, how do you answer this? Here is what you must know. So we're going to have this. I'll make a table. I'll put pen, put first selection, I'll put second selection. Okay. I'll put blue and I'll put green. We know that the total of pens here is actually 13. So whatever outcome, it has to be out of 13. Now let's say we picked blue, okay? In the first place, we are going to have 8 out of 13. 8 out of 13. If again in the second part we picked blue will reduce, since we didn't replace it back, blue become 7. Even the total now will become 12. Here's the thing. If we picked green in the first, green will still remain 5 out of 13. Again, if you picked green in the second, green will decrease by 1, even the total decrease by 1. Okay, so I'm answering question A. So how they say both blue is this part. So both blue, we are saying 8 over 13 times 7 over 12. And this will be 56 over 156. This can be reduced. If you can reduce it, you reduce it. Then B, which is both green, to be 5 over 13 times 4 over 12. This will give us 20 over 156. This can even be reduced to something smaller. This will actually give you 2 over 15 as the percentage, right? Then C, green and blue. Now they haven't specified which one is at the beginning. It's either it can be blue or blue and green, or blue at first then green at the end. This one is the same as different colors, so they can't specify. So what I'm saying here is we can have the probability of green and blue, or the probability of blue and green. Now if you pick green first, you know that green is 5 out of 13. Then you pick blue second. Blue still remain 8, but the total will change 12 plus. If at first you pick blue, blue will be 8 out of 13. If at second you pick green, green will remain 5, but since it's a second selection, the total has already been disturbed to 12. So this is 40 over 156 plus 40 over 156. Then this can be reduced. For example, you can divide 2 there to give you 20. So in short, I have 80 over 156. And this now can be reduced. 2 into 80 is 40 over 2 into 78. You can still reduce this 20 when divided 2 there. 2 here to give you 39. You end there. Just a quick one. I think here is supposed to be 156. Okay. So unless we divide 10 there. Sorry. So we divide 2 here to be 10. 2 here to be 78. But with this can still be reduced. 2 into 10 is 5. 2 into 78 is 39. So the final answer is 5 over 39. That's the answer.